So one note before I forget, I don't have this in my slides, so I have to make sure I remember this one. The lecture questions, they're due at midnight the day after lecture, but I do leave submissions open after that. You can still submit after the deadline. The grading in this course is, of course, different than most other classes. When I do review for the grading your learning objectives, I'm going to look at those 6 lecture questions. Submitting it after the deadline and still getting it correct is going to look a lot better than if you just didn't submit it at all. So those submissions are still open. You can still submit those. When I review the learning objectives, I'll see that it was submitted late, but I will see that you did complete the question, and I can take that into consideration. If you get them all on time, of course, that's going to be glowing, that's going to be great. But if you complete them all, but some of them were a little late, that's still going to look good. So, if you understand unit testing sometime next week, I don't really care that much if you understood it next week or if you understood it exactly at the time that I presented it during lecture this week. As long as you do understand it at some point, that's what I need to assess during the learning objectives. And one easy way for me to know that you understood that, completed that objective is if you just did everything on time. That's going to be a really easy check mark for me. If there are no red flags, check it off. But if you're late, that doesn't mean that you will not get credit for that learning objective if there's still enough evidence there to prove that you did complete that objective. So just throwing that out there. And I'm going through the solution for this one. There's no reason for anybody to not have this submitted, even though it might be late, to not have a correct solution submitted for this one. And since I did rush some of the end of last lecture, I understand if a lot of you didn't complete this question. I wanted to go through a whole live coding example last time, and I didn't quite get to it. So without that, let me not ramble too much or else I won't get to it this time either. So let's jump into this. Here's a lecture question. I'm sure you're all familiar with this question. But then the last slide, I didn't show it, and sometimes I have these hidden last slides. If you download the slides, you can check them out, but I don't show them in lecture. But I had this last slide with some broken implementations of this lecture question. And then when you submit to Autolab, what I'm doing is taking your test code, your tests, your unit testing, that test suite, well, we'll keep it consistent, test suite, and I'm running that test suite against whatever code you submitted, so whatever you submitted for your compute shipping cost method, I'm running it against my correct solution. So I have my solutions, my compute shipping cost method. I'll run it against that. Now your test should pass both of those. It should say both of these implementations of the method are good. It should pass all your asserts. All your asserts should be true on both of those if everything's right with your tests and your submission. It should be able to distinguish both of those. Then I'm going to run it on for each question with testing, I'm going to run it on several incorrect solutions. For this lecture question, I'm showing you what the incorrect solutions are. This is the only time I'll actually show the code. I want to show it for this first one just to make it absolutely clear what's going on in the grader when I give you this feedback. What does that feedback mean? So that means I ran your tests on these 5 implementations of compute shipping cost. All 5 of these are wrong. These are incorrect solutions. These should fail your unit tests. So if you have unit testing that's thorough, that's comprehensive, that's really checking all the edge cases and checking for the correct functionality of the method, those tests should fail all 5 of these. So once your tests fail all 5 of these and pass your code and the correct solution, then Autolab is satisfied. Autolab says, okay, you've completed the Autolab portion of this assignment. That doesn't necessarily mean that your code is correct. It just means that whatever incorrect solutions I came up with, you were able to successfully distinguish between those incorrect solutions and also pass your own submission. Doesn't mean and I'll stress this a lot throughout the semester, it doesn't necessarily mean your code is correct, but if I can come up with an incorrect solution and give it to your test and your test pass that incorrect solution, that is an indication that you did not do enough testing. So we do get that negative of if you pass an incorrect solution, you did not do enough testing. So how do you know that your code didn't make the same mistake that my incorrect solution made? Because you're not testing for that. You don't know if your code makes that same mistake or not. If you do fail all the incorrect submissions with your test, I mean, you got past the ones that I came up with for that question, but there could be some other mistake that I didn't make in an incorrect solution that you didn't test for. So it doesn't mean you can stop. And I saw this in Physics Engine last semester quite a bit. There were a few things that I just wasn't making, that I didn't have an incorrect solution that made particular mistakes that were actually fairly common that students made. So they passed the autograder. Autograder's like, hey, you're good. And then they moved on to the next part. But they had a mistake in their code that they didn't test for, but they were leaning on the AutoLab feedback so much that they didn't discover that. And then when they got to the primary objective, they were tearing their hair out. They came to me in the TAs and office hours going, we cannot figure out what's going on wrong with this. Everything looks perfect. Well, it was because one of their objectives was wrong. They just didn't do enough testing. But they did get my incorrect solutions distinguished. So I just want to throw that warning out there. The AutoLab is not the definitive, this is correct code. It's just saying, with some preliminary testing, just some testing, you at least have a good start for your unit testing and your method. I got ahead of my slides a little. I'll mention that very briefly again. But let's solve this lecture question. So I have this project. I have some of this set up. We'll go into 1 p.m. First, compute shipping costs. We already did the lecture question last Wednesday. If you didn't get the solution, here's that. If you didn't get that lecture question, I guess you can submit this. But here's a correct solution. This is the correct solution that I have in AutoLab. If the weight's less than 30, we're just going to return 5. This could be a less than or equal to. It would have the same effect. And if it's greater than or equal to 30, I'm going to take the weight minus 30, multiply that by a quarter, and then add that to the flat rate of 5. So with this, I'm going to get the correct shipping cost for any value, and it's going to handle negatives. Negative weights will technically cost $5 to ship. Doesn't make sense in the real world, but that's by the definition of the question. That's the behavior we should have. So how do we test this? So I wrote a class named unit testing and a package named, let's change that to test. In a package named test, but I have some errors here. I have my Scala test here, my import is causing some errors. So Scala test is not included with Scala. It's not part of the language. It's not going to come packaged in IntelliJ. This is something that we have to download and link to our project. So to do that, we're using a tool called Maven, and Maven works off of a pom.xml file. The first thing we need to do is go to the root directory of our project, create a new pom.xml file. I'm just going to say new file and name it pom.xml. And then I need content in here that's going to say, hey, this is a Maven project, and go download Scala test. For that, it's a little outside the scope of the class to focus on the details of Maven and the POM files. So on the course website, I have this example pom.xml with Scala test linked to it. And this is why we have to have our versions of Scala exact. The libraries we use, every library, the libraries in Scala have to be compiled for a specific version of Scala. And we're going to use the 2.12 versions of libraries. Some of the libraries, they might by now, I haven't double checked, but some of the libraries didn't have 2.13 when I was setting up a lot of this content. So everything's 2.12 is why we have that version thing. Anyway, I'm going to cut and paste that into my pom.xml. You don't have to worry about changing this. You can change things if you want to look into POM file formatting and all that. There's all kinds of stuff you can modify here, but nothing is required at this point. Once I have my POM file, I still have errors. I didn't fix anything yet. What I want to do is go to Maven in the sidebar here and tell Maven to look for that POM file and download it. This Maven is not always in the sidebar. If it's not in the sidebar, you click this magnifying glass, search for Maven, and then add Maven projects, and then select your POM. Alternatively, you can right-click your POM. Oh, I have to find it in these options. And yeah, add as Maven project, and that'll do the same thing. That'll get that POM linked. Now we can go to our Maven tab, click refresh. Oh, it does it after I linked it. It was already doing it. So now that I have that Maven file running, now downloaded Scala test, linked it to my project, my errors went away, and I'm ready to start testing code. So that's how we set up the project. That's why I rushed through at the end of last lecture. And since I did rush through that, did I mention this or not? But the lecture question on Monday, obviously know that I rushed that. So if you didn't get that question and you submit it late, I'll take that into account when I'm looking at this learning objective. So we want to test our functionality. So one way we can do that is just start writing some assert methods. Assert. First object. That's what I was afraid of. IntelliJ, stop chewing up my CPU. 300% CPU, come on. So if I want to compute the shipping cost, let's compute the shipping cost of 10. And I'm going to, lest you think I am making mistakes up here, I will purposely make a lot of mistakes today so we can talk about what those common mistakes are. So I am doing this on purpose just in case you're wondering. But we want to make some mistakes. We want to see some errors because I want to simulate what you're actually going to see. A lot of lectures, if we don't do live coding, everything just is so pretty and shiny and perfect because we already went through the mistakes offline. But I want to go through a typical process of what mistakes you can make, what those mistakes are going to look like, and what's going to happen with those. So if we have a package of weight 10, that's going to cost $5 to ship. So I have my first test case. I'm going to assert that and make sure that this is the case. And let's run this. Let's run this thing. Anybody want to shout it out? What's the first mistake I already made? I'll get away with it in this case, but what's the mistake I made here? So I get passing all my tests. All right. So if I do something like this, this is going to be 30.3. 0.3 pounds times a quarter. I expect this to be 0.75. If I run this test, I should be failing this test. Really, I should be passing it, but I'm going to fail this test. This is the first mistake. This is what we talked about with doubles. And Scala test is going to give us some nice output here. It does try to help us out as much as it can. So did not equal what we put in. This value is what we expected, but we actually got this value. We got our loss of precision. We got our error when comparing doubles. We cannot compare doubles with equal. We will get ourselves in trouble with this. Once we start doing some math on values that have a loss of precision that can't be represented exactly in a double, we're going to get these errors. This is something we can't do. No equal here. So instead, I'm going to write a quick method. Compare doubles. We're just going to take two doubles and just compare them in the way that I want them to be compared. Return a Boolean. I just want this to compare doubles. Math.abs, quick typo, 1 minus 2 less than less than some very small value. Which we usually call epsilon in math courses and computer science, in anywhere where we're dealing with these small values. If we have some value that's supposed to be a very small value, we usually call that variable epsilon. Just a little convention. So now I'm going to be able to compare these doubles using my method instead of equal equal. And at this point, we should correctly pass this test. We're at least within 0.000, however many zeros I have, 1. We're at least within this allowed tolerance of each other. Then we're going to say these doubles are effectively equal within some truncation errors, within some rounding errors that we're not concerned with. So we're passing our test there. We're happy with that. Now, of course, this is not enough testing. There are a few of those incorrect solutions where this test is not going to fail them. It's going to say, hey, this solution, it's good, even though we know that code's wrong. This is where we want to add some more test cases. Now, at this point, we can just start jamming our code full of test cases. I mean, that'll work for us. But this is going to get cumbersome at best. It's going to get hard to maintain, hard to read, hard to expand, and just kind of ugly code in general. So what we want to do is clean this up a bit and use, a lot of you, I saw this in office hours, a lot of you were using lists just because that's what I used in lecture. You started with that code and then started using lists. One of you I talked to in office hours yesterday had 2 lists, one for the inputs, one for the outputs, and tried iterating over both of them at the same time to be able to get the input and output behavior. I want to show one way to make this a bit cleaner, and that's going to be to use a map. So I'm going to create a map of test cases. Oops. In this case, my inputs are doubles, my outputs are doubles. I'm going to create a map of just some of the values I want to test. So 10 should return 5. 30, I'll test my endpoint, should return 5. 31 should return 5 1/4. 30.5 should return $5.12.5. And let's leave it there. Of course, we would want more and more testing as we go, but I'll stop there for now. You get the idea. You would want lots and lots of tests here. We would want to test our negative numbers. We would want to test values closer to 0, etc. But I want to set up the structure and show you how the structure works. That's what I'll focus on here. This wouldn't be enough testing. Maybe it'll just happen to get through the 5 incorrect solutions and mark them all wrong. It might, I don't know. I'd have to look at it a little closer. But this is not, I would say this is not enough testing. You should do more testing than just these cases for this question. But let's set up the structure here. I want to iterate over my test cases, input and output. For input and output in my map, in my test cases map. I'm going to give it the input and expect that output and throw that into my equals doubles. If I run this, we won't get to see much. It's just going to give us the same green bar. But what if we break this method? I'm going to give the wrong output now. We should see our test fail at this point. We have an incorrect solution. My test case better fail. In fact, it does. It's going to give me some output. It says, this resolved to false on this line. Well, great. That really doesn't tell me much, though. My test failed, but I have no information. This is where we use that second argument, where we get to give some actual meaningful feedback here. So for this one, you can format the string and give yourself a nice, meaningful message. It's highly recommended. For now, I'm just going to say what input gave me that wrong solution. So I'm going to give this a second argument, and that's going to be what's printed to me if this assert fails. So now, instead of just failing, it's going to give me my string that I told it to give me. It's going to say, hey, this test failed, and here's your, what we call hint text. Here's the hint text that you told me to print if this assert ever fails. So now I know on input 10, I failed. Okay, 10, that should return 5. I can go to my object. Okay, if this is 10, trace through my code, that's less than 30. Oh, crap, I'm returning 5.5 instead of 5. Let's fix that. Fix this, get our test passing, and then we're going to be more happy with this. All right. Any questions on this example before we move to the next one? Yes? Oh, can I go to that one? Yes. Oh, and one thing, I want to hear your question, but just one thing I forgot to mention. To run the test, right-click and then run. There's no main method, so you don't get your green arrows in the gutter over here. You do have to right-click the file to run it. But go ahead.
So, people just, it's the last one. So, so when you do the assert line, it's going to compute the shipping cost with those two numbers, input and output. It doesn't only return one number.
So right here is the call to my compute shipping cost method. This is going to return a number. This is whatever my method does on that input. And then the output, this is what I expect the output to be. These are the keys in my map. So for this first value in the map, the input will be 10 and output will be 5. I'm grabbing these various variables out of the map here and then calling my method with input. This is going to return whatever my method returns. And then I'm going to use that as the first argument in my compare doubles method. That's going to be the 1 here. And then the expected output here will be the 2. So I can test using my tolerance, allowed tolerance there. And then this is the method that ultimately returns the Boolean that I'm going to assert. I want to assert that that Boolean is true. Any other questions on this one? Let's keep on cooking. Okay, so just a few reminders to recap. Never use equal, comparing doubles. That's going to get you in trouble. It's not a good way of doing things. Using that map to store your test cases. Remember these data structures. Actually, I don't know if I mentioned this lecture specifically, but data structures, the types can nest. You can have a map of integers to lists of arrays of strings. You can nest these types. Anywhere where there's a type, you can put any legal type. So in the type parameters can be any of the types we know, including maps, arrays, and lists. So if the output is going to be lists, like we're going to see for the next example, we can have a map of ints to lists of ints, or strings to lists of strings in the next example. Ints, I was thinking of the lecture question. Lecture question, you want a map of ints to lists of ints if you want to clean up your code with a map to have lots of test cases. The one huge advantage of the map, it's really easy to add more test cases. After you have some test cases, you want to add a few more. No big deal, you just add a few more key value pairs to that map. You don't have to cut and paste big clunky lines of code, especially when your tests get more complicated. It gets really cumbersome. I won't harp on it here because I want to get to the next example, but how much testing is enough? Well, more than you need to satisfy AutoLab. I'll leave that as the reminder here. Enough to convince yourself that your testing is complete. Don't just try to satisfy my auto graders. Don't just try to see what's enough for me to think that you have enough testing. Convince yourself that if your code passes those tests, it should be correct. What does it take to convince you that your code is correct? That's how much testing is enough. Unless you have very low standards, then it might not be enough still. But convince yourself that your testing is enough. Okay, let's get to the next example. This one's going to be a little trickier. This is where we're going to see about comparing lists. I want to talk about comparing lists a bit. Write a method that takes a string and returns a list of all the anagrams of that string. So an anagram is if you rearrange the letters to create a new word, that word is an anagram of the original word. So given an input word, give me all of the possible anagrams for that word, and of course, write a test suite for it. This is what I want to walk through. I lose my cursor sometimes when I do that. All right, so and this is where I will write an incorrect solution to this a few times. I shouldn't even mention that, right? Anyway, I want to write this. I didn't specify any name to this. I'll say anagrams of some input string, and we need to return a list of all the anagrams. What am I doing? There we go. And I need to return a list of all the anagrams. So the first thing I want to set up is the list that I'm going to return. I need some output list of strings that's going to contain all of the anagrams. I'm going to initialize it to empty, and I'm going to make sure that's the last line of my method, so that's what's being returned. And as I do live coding, just something you'll notice about how I develop, I'll rarely write my code in order of the method. I'll jump around as my train of thought takes me. I'll code in the order of my train of thought, not in the order of lines of code in the final method, which I recommend. I mean, whatever works for you, of course, but I recommend not just writing this line, then this line, then this line. Try to organize your thoughts. Okay, I need to create a variable that will be returned. I have my first and last line. Now, what needs to go in the middle here? So here we can, what I want to do is iterate over the characters in this string. And for each character, I want to come up with all of the anagrams with the remaining letters, and then add that character to that list of letters. This will get tricky. There's not necessarily an expectation for you to understand this code, which is the entire point of our testing. What happens when you see code that you don't necessarily know if it's correct or not by looking at it? Here's where we're going to need some unit testing. So let me iterate over the characters of the input string, and I want to pull that character out. Actually, I messed this up already. I want to iterate over the indices of the characters of the string. Remember, strings are actually arrays of characters. So I can iterate over the indices and kind of treat this as an array, as an underlying array of characters. So I'm going to take my input dot. So I want to be concerned about the length of this input. And I'm going to use until. It's the same as to. I want to iterate over the indices of the characters. I'm going to use until. It's the same as to, except it doesn't include the endpoint. I actually had a typo in my slides and in my examples repo. In the last lecture, I had 0 to some array dot length. That wasn't. That actually included one indice that was off the edge of the array. I fixed it, I updated things. But we want to use until or 0 to input.length minus 1 to iterate over those indices exactly. Let me get the character. Let's call it char equals input dot char at that index. And I want to know what I'm left with after I remove this character. So my new string is going to be the input with the substring of the input from the beginning of the string up until that index. Substring does not include the end point. It includes the start point, but not the end point. So this will not include the character index I, which I'm removing. And then finally, input dot substring I plus 1 input dot length. And here's where we can actually leave off these parentheses. Oh, not that parenthesis. We can actually leave off the parentheses on length. It is a method call. Sometimes Scala lets us leave off the parentheses. I meant to look up the exact rules of when you can and can't, but this is one case when we can leave off the parentheses. So now I have this new string, which is going to be all of the characters except the one that I just removed. And what I'd like, if I can, through some magic that we'll see, get all of the anagrams of that new string, I can append that character that I pulled out to all of those anagrams, and that'll give me all of the anagrams to my original input string. So how are we going to get all the anagrams of this new string? Seems like we didn't get anywhere here. But if I'm claiming, stick with me here, if I'm claiming anagrams will compute all the anagrams of a string, why don't I just use my method that I didn't even finish writing? That's going to give me all the anagrams That's going to give me all the anagrams of that string. I'm going to iterate over those. And in my output, I'm going to append that anagram plus the character that I removed. So if this is computing all of the anagrams of that new string, so I have this string, I'm pulling one character out and getting all of the anagrams of what's left. I take all those anagrams of what's left and then add that character that I pulled out to all of those. And if I do that for every character in the string, then I must have all the anagrams. Seems legit, right? So if the anagram method works properly, then the anagram method works properly. Because I'm using anagrams to write anagrams. Makes enough sense, right? So you shouldn't just believe me that that works. And this is where testing comes in. So that's a tricky method. That's a weird thing. It's called recursion. We will talk about it later in the semester. But that's a weird thing that we just did. We're using a method to write a method. That it shouldn't work like that. So let's do some testing and check if, I'm going to cheat a little in the interest of time. So I want to check if those anagrams are actually correct. So we're in 1 p.m. Oops. Oh my goodness. 1 p.m. Import. Oops. Oh my goodness. Do it for me. 1 p.m. anagrams of the input. I want to make sure this equals the output. I don't need to compare doubles anymore. And I might as well give input back. Next, I need to change the types of my map. And I need some input. So let's say we want to find all the anagrams of the word A. Is going to be a list containing just A. If I want to find all the anagrams of the word, anybody got a word, a short-ish word? It's not.
Fox.
Fox, thank you. That's not a swear word I was going to say. Y'all did good on that one. All right, fox. So all of the anagrams of this are fox itself, FXO, XFO, XOF, quotes, OFX, and OXF. Did I miss any in there? That should be right. And then we want to run this. And test our code. Do we think this is going to pass or not? No, not at all. This is going to fail. I ran the wrong test suite. I was running unit testing still. I tried to use the shortcut. This will run the last thing you ran. The last thing I ran was unit testing. I got to run the right class. Once I run the right class, no, boo, this fails. So, so my output here, the Scala test gives me, list, empty list did not equal list of A, and then it gives me my string. The input was A. Of course, it's giving me some pretty good feedback in there anyway. So I returned empty list. So if you believed me that this would actually work, well, you shouldn't be that naive. This doesn't work. This will work. We'll get it to work. But there's one big problem here. I'm creating an output list. It's an empty list. I'm appending to it only when I get an output from anagrams that's not an empty list. Then I can start adding things to this, and then I return that list. But how can I ever append to this list by getting something from the output of anagrams? Like something has to output something. Something has to add something to this list without requiring that something was already added to this list. So the big mistake I made here is if input dot length equals 1, if I only have one character, I'm going to handle this as a special case. This is what we call the base case of our recursion. I'm going to return a list containing just that input. Now if I go back to my code and just quickly, I want to, you can format your maps. When you have a lot of test cases, sometimes it's better to put this on separate lines. I'm going to comment out this one for now and make sure that this A at least works. This should at least work because input is size 1. It's just going to trigger my conditional at the end. And I put input in quotes. Oh my goodness. Yeah, that will break. That one was not intentional. So this one should work. Nothing. All that magic in the middle is not going to happen. I'm just going to say input is length 1, return itself in a list. There's nothing too interesting here. But what about Fox? Is this one going to work or not? I myself I'm on the fence a little bit on this one. So this is why we really need unit testing. I think I have a bug, but I'm not positive. Okay, we do have a bug. Good. So this is where unit testing comes in. I wasn't even sure if that was going to be correct or not. I was a little on the fence. So we do have a bug in here, and if we look through our output, we can start getting hints of what went wrong. So, oh yeah, obviously. This is one of the big points of this example. So if we look at our output, this actually looks right. So that magic did happen. That does work, by the way. We will talk about that later in the semester when we get to recursion. But using a method to write a method, using itself, calling itself, this is a recursive method. It actually does work. We did get the right output, but this right here is what I want to talk about. When we want to compare two lists, there are a few ways we can do this. Scala gives us this convenience of just saying equal, equal. If these two lists are equal, which means they had to have all of the same elements in the same order, then Scala is going to say true for this. The equal, equal method is pretty powerful here. It will call equal, equal on each element. So as long as these lists are the same size, it's going to step through all the elements in each list, call equal, equal on each of them, and if all the elements stepping all the way through return true on the equal, equal method, then this is going to return true. However, the problem never specifies any particular order for the elements to be returned in. So we do have proper behavior. We have the right values for our anagram, but we're failing our test because they're not in the order of our test case. This is something that we don't want to fail a method for. The method's working fine on this input, But we want to be able to take care of that. One quick way to do that, and what you'll have to do in your testing for the lecture question, is handle this in some way. Quickest way to do that, sort them both. Sort both lists. Now your order doesn't matter anymore. Whatever the orders were in either of these, we're going to sort them both. If they contain the same elements, now they're going to be in the same order. And now we get our green bar, our green check mark, passing our tests. So we're feeling good, right? The method's completely correct, right? If you've been paying attention at all in the last 2 lectures, you better say no to that. We only have 2 test cases. Of course, this is not comprehensive testing. Now, with enough conniving and salesmanship, you could probably convince somebody that this is comprehensive testing. What else could go wrong? What inputs could we go wrong on for this? Like this is a tough example to get. If your method is right on this one, it's probably going to be right on just about every single case. But what can happen here? What is some input where my method is going to break? Yeah, Lana, our TA is allowed to answer this. Yeah, Lana. No? You sound like you had something good there. All right. So, where do I want to? Need a short word. First word I thought it was 5 letters. I don't want to do a 5-letter word. On
Different language.
Off, yes. Off is a perfect one. So off itself. So these are the anagrams of off. There's only 3 of them. Now I'm going to fail this test case. So there's only 3 anagrams, but I'm returning 6. I have each one of those twice because my code is treating that double F. That's treating both Fs as completely separate, independent characters. So here's where my method is getting something wrong. It is technically returning all the anagrams, but it's returning a lot of duplicates, a lot of extra stuff that shouldn't be in there. If I'm calling this method saying, hey, give me all the anagrams of this word, I really don't care about those duplicates, especially if you're doing something like dot length on the list of anagrams. How many anagrams does this have? And it's always saying the permutation of those letters, choose that many letters. If it's always giving that value, like that's not too interesting. So we got to fix this. Quick way to do that is when we're adding, I'm going to give a quick conditional here. If output dot contains, I want to check if, oh my goodness, if my output already contains this word that I want to add, if it already contains that word, I don't want to add it. So I'm going to say if it doesn't contain that word, then add that word. So a quick and dirty check. There are other ways we can do this, but this is the quick addition that we can make to our code. What word am I trying to add? If my output already contains that word, don't add it. If it doesn't contain that word, then add it. And here we should be passing this test case. Should. Should is a strong word. Yeah. That happens. That's part of live coding. FFO. I had a duplicate in my test case itself. It happens. Sometimes the test cases themselves are wrong. What can I say? It happens. All right, so to recap, we can compare lists with equal. The order must match, though, the size, the order, they must match. But we can sort both lists to get rid of that. And when do you know your code is correct? Well, write a lot of tests. See everyone Friday.